What's up YouTube, this is Demkeys back again with another Unity tutorial, and this is going to be chapter 2 of the Make a 2D Platformer game series. In the previous chapter we created an empty project, imported sprite sheets, and later sliced those sprite sheets to get individual sprites. In this chapter we are going to see how to create character movement. So let's begin. What we have here is an empty scene. The first thing you need to do is add a quad. That's game object, 3D object, quad. And this is going to be our ground object, so let's rename this object to ground. This is the hierarchy panel. Whatever is present within the scene is going to be there in the hierarchy. So if you've got a really big scene and you've got many objects scattered around here and there, you don't necessarily need to go and find them. You can just look for them in the hierarchy, and then okay, let's say I'm over here and I don't know where my ground object is. I can just double click the ground object and it focuses on the ground object. Let me change the layout before continuing. Okay. Alright, now this is going to be our ground object, so let's stretch this out a little and make it a little flat. Yeah, I think that's good. Maybe a little more. Alright, the next thing we need to do is remove this mesh collider because we don't need this. What we need is a box collider 2D component. So click add component, physics 2D, and box collider 2D. To add a component to this object you have to have the object selected. So if you don't have it selected, then select ground from the hierarchy first and then go ahead and add the box collider. Next we are going to add a sprite to the scene. Drag this sprite onto the scene. As you can see, a sprite has been added to our scene, and also, well, a game object has been added to our scene and also to the hierarchy. First thing we need to do is rename this object to player. And now let's look at the component that's attached to it. You have the transform component, which tells you the position, rotation, and scale. And then you've got the sprite renderer component. This tells us that this object is actually a sprite. Now the sprite renderer component has a couple of properties. Sprite, which is the actual image being used for the sprite. Color, which gives you the option to shade this object in different colors. I'm going to leave it white. You can also attach a specific material to it rather than using the default sprites material, and then you've got other options as well. Alright, let's add a rigid body 2D component to our sprite. Hit add component, physics 2D, rigid body 2D. Rigid bodies basically make this object interact with Unity's physics system. So they add things like mass, which is weight of the object, linear drag, which is basically drag that is applied when you try to apply force to the object trying to move it. You have angular drag, which is drag applied on the rotational force if you try to rotate this object. Gravity scale, which is basically the gravity that is applied to the object. You can actually set the gravity, you don't have to leave it to 1. You have fixed angle. This stops the object from rotating. If you don't want it to rotate, you want it to be straight, then you can set fixed angle. I'll show you shortly what is kinematic does, and I'm not gonna explain these three options. Go ahead and do your research. Alright, so let's run the game and see what happens. Bring this object a little higher than the ground. As you can see, the character has gone through the ground. The reason is that there is no collision taking place. So we need to add a box collider 2D component to our player. I've previously done a video on collision detection. The link is mentioned on the screen right now and in the description down below. So check it out if you don't know how collision detection works. The video teaches you how to use colliders and triggers. So let's continue. Let's run the game now. And now our player is stopping at the ground. Now what does isKinematic do? isKinematic basically stops this object from communicating with the physics system. So things like, for example, if you try to add force, the object is not going to move. Gravity, weight, nothing is going to affect this object. So currently mass is 1, gravity scale is 1, so this object should hit the ground when I run the game. But that's not going to happen because I've checked isKinematic. As you can see, this object is just stationary. The next thing we are going to do is attach a script to our player. Create a scripts folder. Like I mentioned in the previous video, I'm only doing this because I like to keep things organized. You don't have to do this. I mean, you have to create the script, but you don't have to divide everything into different folders. I'm going to call this player move script 04. Now we need to attach this script to our player object so that whatever is within the script will actually affect this character. There's a couple of ways that you can attach the script. One, drag it to player in the hierarchy, or you could drag it to the player object in the scene view, or if you have the player object selected, you can drag it into the inspector panel at the bottom over here, or you could hit add component, scripts, and then select the script that you want. Alright, so we're going to open up the script in MonoDevelop. MonoDevelop is an IDE or integrated development environment. This is what you're going to use to write your scripts. Unity supports 3 languages: C#, JavaScript, and Boo. You can do scripting for all 3 languages in MonoDevelop as far as I know. However, if you are using C#, which is what we are using right now, you could also try out Visual Studio instead of MonoDevelop. I prefer MonoDevelop, so I'm going to go with that. I don't know if JavaScript and Boo are going to work in Visual Studio or not, but for C#, yeah, you can definitely try Visual Studio. Alright, now I'm not going to go into a whole lot of detail with scripting because this is not a scripting tutorial. So if you are a complete beginner to scripting and you know nothing about programming, don't worry, just follow what I'm doing, and hopefully you'll learn a little something about scripting and programming along the way. Before we continue, let me inform you that this tutorial is not meant to teach you scripting. So if you are hoping to learn scripting by watching this video, don't, because there are plenty of other tutorials that you can find which are specifically for scripting. This tutorial is focused on making a 2D platformer game. Alright, now the first thing we need to do is add a public float variable called moveSpeed. We write public here so that this variable is going to appear in the inspector panel in Unity, and so I can actually change its value. I can set a specific value without having to write it in the script itself. Next you have float, which is the type of variable that this is, and then you have the name, moveSpeed. Next, public float jump speed. Alright, so the game is running in frames, right? So start is called before the first frame update, and this is only if the script is actually enabled and that game object itself is enabled as well. Update is called every frame. So most of our, in fact for this tutorial, all of our coding is going to be within the update function itself. Alright, float h equals input dot get access raw. horizontal. What this line does is it's going to create a float type variable called h, and within that variable a value is going to be stored, which is what is returned by getAxisRaw. GetAxis in this case is going to tell us whether the A or D keys or the left or right keys are being pressed. If A or the left arrow key, if either of them are being pressed, then the value is going to be -1, or it's going to start moving gradually from 0 to -1. And if the D or the right arrow key is being pressed, then the value is going to move from 0 gradually towards +1. If none of the keys are being pressed, then the value is going to be 0. Now this is in the case of getAxis. When you say getAxisRaw, then the value is going to jump between 0 and -1 and +1. It's not going to be anything in between. It'll be either 0 or -1 or +1. And then that value is going to be multiplied by move speed. So if move speed is, say, 200 and no key is being pressed, then the value of h is going to be 0, because input.getAxisRaw gives us the value 0 when no key is being pressed. If the left key is being pressed, then the value will be -200, and if the right key is being pressed, it's going to be +200. Next, rigidbody 2d.addForce, new vector 2, h along the x-axis and 0 along the y-axis. Alright, this line basically first looks for a rigidbody 2D component attached to the game object that this script is attached to. And if there is a rigidbody 2D component attached, then it's going to apply a force to that object. Now addForce takes a vector 2 parameter. Rigidbody 2D.addForce takes a vector 2 parameter. If this was a rigidbody component, not rigidbody 2D, then I think it would take vector 3. So in this case it takes a vector 2, so we can apply force along the x-axis and along the y-axis. For now we just want to control horizontal movement. We don't want any vertical movement, at least not in this line. So we are applying 0 force along the y-axis. Don't confuse this with setting the position of the object. We are just applying a certain amount of force to that object along a certain axis. We are not setting the object in a certain position. Alright, next we are going to create an if statement. If input.getKeyDown, key code dot space. Okay, this is an if statement. Within an if statement you can provide a condition. So if this condition is true, then whatever is within this if statement will be executed. What is the condition? The condition is input.getKeyDown. Input.getKeyDown tells us whether a certain key is has been pressed once. Which key, we can specify that, and in this case we have specified keyCode.space. That basically means the spacebar. If you want to specify some other key, you can just type keycode dot and then an entire list will be shown for you to select from. So let's change this back to space, and then we want to apply force vector 2 dot up multiplied by jump speed. Alright, so you already know what rigidbody 2D.addForce does. Vector 2.up is basically a short way of writing new vector 2, 0 along the x-axis and 1 along y. This is basically a short way of writing this. So vector 2.up multiplied by jump speed. So just so you know, in this line we are applying force to the x-axis, and in this line we are applying force to the y-axis. Now let's save the script. To save the script, you hit Control S and then go back to Unity. And if your script does not have any errors, then you should see these two variables shown over here. Let's set the move speed to 10 and jump speed to about 350. Now let's run the game and see if this works. Before running the game, we don't really need to look at the game view, so select the game view and drag it over here. Now run the game. Oh, sorry about that. I forgot to uncheck is kinematic. Now run the game. And as you can see, our player is able to move and jump. Alright, so this is really basic movement, right? Notice that if you press the space bar more than once, the player does actually jump multiple times. And we don't want that. We just want a single jump. It depends upon what kind of game mechanic you're trying to set up, but in this case we just want a single jump. So we need to add a jump validation for that. Alright, so the first thing we need to do is okay, stop playing the game. Then what we need to do is create a child object, click have player selected and click game object, create empty child. That's going to create an empty child object within the player game object. Let's rename this to ground check, and let's change its icon so it doesn't show up as just, you know, something blank. Click this cube over here and then you can select the icon for the object. Now place this object below the player's the character's feet and leave a little space between the object and the player. Alright, now select the ground object, not the ground check object. Select the ground object and see where it says layer over here. Click that, and now under user layer 8, write ground. So we have basically created one of our own layers. If you're wondering why these are grayed out, this is because these are built-in layers that are used in other cases as well. Alright, now we have to make this ground object a part of the ground layer. To do that, select the ground object in the hierarchy and select layer and select ground. Now let's go back to the script. Alright, before we continue, let me mention, generally physics calculations, things that deal with rigid bodies, etc., are done within fixed update instead of update, because update is called once per frame, but fixed update is called multiple times. But for the purpose of this tutorial, I'm going to stick with update. Alright, now first we need to create a public bool, call this isJumping, and set this to, actually we don't need to set it to anything, it's fine. What next? Yeah, public game object ground check object. Now create an if statement. If physics 2d.linecast transform.position as the first parameter and as the second parameter ground check object.transform.position, and as the third parameter just copy this. Okay, so what's going on here is this is an if statement, as you already know. The condition within the if statement is if physics2d.linecast. In this case it means that if linecast does actually hit something that that is a part of the ground layer. Physics2d.linecast basically casts a line from one point to another, and along its journey, if the line hits any collider, it reports what it has hit. The first parameter is the start point of our line, and ground check object dot transform dot position is our second point. Transform dot position basically means the position of our current game object, the game object that this script is attached to, and ground check object is an object that we'll be specifying later on, and we'll be accessing its position. And then the third parameter is which layer are you looking for. Then is jumping is equal to false. So if physics2d.linecast, if the line actually hits a collider and that collider is attached to an object that is a part of the ground layer, then it's going to return true, in which case this statement is going to execute. Else if, well, in this case there's no else if, in this case just else. Else is used in case if this returns false. Not this. If this returns false, then else will be executed. So else is jumping is equal to true. Now above rigidbody 2d.addForce new vector 2, write another if statement. If not is jumping, and let's just space these properly. Okay, now this if statement basically says that if is jumping is equal to false, not is jumping, that is the exclamation mark is jumping. This is a short way of writing is jumping equals to false. You use double equal to for comparison, but instead of writing it in this way, we can just write not is jumping. So if is jumping is equal to false, that clearly means the player is not jumping. Then we want the player to be able to move and also be able to jump. Else if, well, do we need an else if in this case? No, I don't think so. Let's save the game. Let's save the script and go back to Unity. And now when you select the player object, you should see two new variables over here. One is jumping, one is ground check object. Click and drag your ground check object from the hierarchy into this. You're not actually removing the ground check object from there, you're just adding a reference to this object over here. So now what's going to happen is a line is going to be cast from this object to this object, and when our player is on the ground, then the ground check object is actually going to be somewhere here, not above the ground, because the collider is attached to this sprite, not to this ground check object. Let's run the game and see if this works. As you can see, the ground check object is here. So now when the line is being cast, it's going to return true, and so is jumping will be false. If you click your player object in the hierarchy and look at the script, is jumping is false. Now you must have noticed that you don't have control of your player anymore. This is because we clicked on the player object in the hierarchy. Just click once on in the game view and you should have control again. Now try jumping and notice what happens to is jumping over here in the inspector. As you can see, it becomes checked for that short period of time that you're jumping. And if you try to double jump or move anywhere else, you can't do either of those things because you are currently jumping. Alright, so we have now successfully added a jump validation to our player object. Oh, by the way, I forgot to mention, this right here is known as bit masking. If you want to know more about this, then I've done a video on layers and layer masking. The link is provided on the screen and in the description down below, so go check that out. Alright, so you must have noticed that our player is always looking towards the right side being your right, not the player's right. And when you try to move towards the left, the player doesn't look to the left. We need to change that. For that, we are going to change the local scale of this object, not ground check, sorry, of player. Now scale basically sets the size of our object. We can set the size along the x-axis, y-axis, and z in this case doesn't matter, but you get the point. Now currently it's set to +1. Watch what happens as I slowly move towards 0. It becomes smaller and smaller. When I go into the negative values, it starts to expand in the opposite direction, and at that point our player is looking towards the left. So this is what we need to do. Set this back to +1 and go back to the code. And if you remember earlier, I mentioned that h, the value of h, is going to be either negative or positive depending on what kind of key is, which key is being pressed. And if no key is being pressed, it's going to be 0. So we can use that logic and set the scale of our player. If h is greater than 0, transform.localScale is equal to new vector 3, 1 along x, 1 along y, and 1 along z. Else if h is less than 0, then transform.localScale is equal to new vector 3, but this time -1 along x and same +1 along y and +1 along z. Let me explain else if. Alright, so you know what if does. You know what else does. Else if is basically if you want to provide a second condition. So we can have if h is greater than 0, then the player is looking towards the right side. Else if h is less than 0, the player is looking towards the left side. So save the script and let's go back to the game. Click anywhere in the scene view so you don't have that position handle on your player. Then run the game and notice what happens when you try to move the player towards the left side. The player is actually looking towards the left side now. Alright, so now our player is able to look both left and right. Next, we need to add a velocity limit to our player. If you notice, the player's velocity builds up as you keep moving forward. If you keep your finger on the key for a long period of time, the speed is going to build up, and then eventually the player is going to just go off the screen. Sorry, go off the ground object. We want to add a velocity limit so that no matter how long you keep your finger on the key, the velocity stops at a certain limit. It doesn't just keep increasing. In order to do that, first let's take a look at the velocity of the player. Create a public float object called player velocity, or player vel in this case, and in the update function at the end, just before the closing bracket for the update function. You can find that out because when I have my cursor on this line, this is the closing bracket for the update function, and this bracket here, which is the opening bracket of the update function, is highlighted. If I move further down, this is the closing bracket for the class, so that is highlighted. If I click over here on the closing bracket of start, the opening bracket of start is highlighted. Alright, so go to the end of the update function and write player vel equals rigidbody 2d dot velocity dot x, because we want to find out the velocity along the x-axis, not along y and z. Save the script and go back to Unity. Select your player object and make sure you can see the player move script as well. This is player velocity. Don't set this to anything because this is going to change as our player starts to move. Now run the game and try moving your player. When you're moving to the right side, you can see the velocity in positive, and when you move to the left, it's in negative. But as you can see, it keeps increasing. We want to set a limit for this velocity. Let's create a public float variable called player vel limit, and within this if statement, if not is jumping, we are going to add something called a nested if statement. If h is greater than 0, keep this separate. So if h is greater than 0, which means the right key is being pressed, then if rigidbody 2d dot velocity dot x is less than player vel limit, then add more force so that the player can move. So basically, if first of all not is jumping, then if the right key is being pressed, then if the velocity on the x-axis is less than the player velocity limit that we are setting, then add force to the object. Now we are doing this, we are adding this extra if statement over here because when you're comparing the velocity, if the left key is being pressed, then the velocity is actually going to be negative, and so in that case the comparison kind of becomes opposite, because positive 4 is greater than positive 3, but if you look at negative 4 is actually less than positive 3. No, sorry, negative 4 is actually less than negative 3. So in this case we need to change it. Else if h less than 0, then copy this entire thing, but change the comparison to greater than negative player velocity limit. So if we set the velocity limit to say 4, then it's going to look at the negative value of that same velocity limit, which will be negative 4, and so when you're moving towards the left side, the velocity is going to keep moving in the negative direction, and so it's going to go, negative 1, negative 2, negative 3, and it's going to stop at negative 4. It's not going to go any further from that. Now let's see if this works. Before running the game, we need to set the player velocity limit. Let's set it to, say, 3, and let's change the move speed to, let's say, 20. Now let's run the game. And as you can see, our player's speed is not increasing more than what it's supposed to be, even when you're moving to the left direction. It may say positive 3 over here, but in our logic we are first converting it to negative and then comparing it. Alright, so we now have a player velocity limit. You'll notice when you let go of the key after moving your character, the character still moves a little bit. This is because due to the force being applied, the character still has some momentum. So we want to set the velocity to 0 as soon as the key has been let go of. First, stop running the game. Now go back to your script and within if not is jumping, where you just created these two if statements, below that write else if. So that's a second else if, h double equal to 0. This basically means if h is equal to 0. This is a way of comparing. You cannot write single because it's going to give you an error, because that is a way of setting the value of h to 0, and you can't do that within like when you're specifying a condition. Alright, so if h is equal to 0, then rigid body 2d dot velocity equals new vector 2 0 on x, but rigid body 2d dot velocity dot y on the y axis, because the velocity along the y axis is actually its jumping speed, so we don't want that to be affected. We just want to stop the horizontal movement of our player when the key is let go of. Now let's save the script and go back to the game and run it. As you can see, the player stops when you let go of the key. Alright, so we have now set up character movement for our player. I'll be providing a link to chapter 2, which is this project, in the description down below. Stay tuned for more. I hope this tutorial was helpful. Do check out these other videos as well. The video on the top left teaches you how to use the line renderer. The video on the top right teaches you how to use lens flares, and on the bottom left is a playlist for the Unity 4.6 UI Tools series. I'm also accepting donations, so if you would like to help me out, you can send your donations to my PayPal email address, which is mentioned on the screen and in the description down below. Don't forget to like, share and subscribe. Leave your comments below, and I'll see you guys next time.
This is what they saying. What? How you feel, huh? This is what they saying. What? Yo, started out with nothing, then I turned myself to something. Everybody wanna claim a nigga when you hear you buzzing. Don't nobody wanna claim you when they hear you bugging. Not known to tell stories, not known for fronting.